Hello, I am Ellen Shapiro, and I'm here to talk to you guys about UI testing today. One of the things that I always hear when I'm talking to people about adding tests to their applications, why would you want to add UI testing? And part of the problem with that is that it's really hard to know where to even begin with testing. You know, lots of tutorials and methods of testing assume that you're starting from scratch and that you have full control over the code base that you're working with, and you have full opportunity to architect it properly from the beginning so it can be tested in isolation. But if you've developed professionally for more than about 5 seconds, you know that that is a very rare case. So even if you do have those unit tests, which test that everything works in isolation, sometimes there are pieces that don't fit together quite right or behave in ways that you don't expect. And UI testing is actually really helpful for both of these circumstances, because you make sure that all of the pieces work together for your users, and then you can get way more granular. You're creating a safety net for yourself by making sure that things are always working for the users. With those UI tests, you have this assurance that you haven't broken anything user-facing with your refactoring. Now, I'm going to talk a little bit in a second about the history of ways you could UI test your app, but all the UI testing methods that I'm going to talk about here have one thing in common, and that's the use of accessibility methods to tell the test methods where to tap on the screen. So accessibility, when used by blind or otherwise visually impaired users, reads the contents of the screen out loud so that they can figure out where to tap to interact with the screen. But since a computer has no eyes, it is essentially a blind user. It needs to know where to tap, but tying it to a specific X and Y point on the screen would make it really difficult to test multiple screen sizes, and you'd have to do tons of test updates every time you updated your UI. So by using accessibility, tests can use existing APIs to access parts of the screen that it can't see visually, and then let your UI be tested. So, where did we start with this? So the terrible old way was a library called UI Automation, and it was built by Apple to facilitate user interface testing, and that was the good news. It was targeted more at QA than developers, and because of this, it was written in JavaScript. And you had to write every single test in JavaScript, and you know, why would Apple do that? That's crazy, because JavaScript is horrible. And it's mostly because, particularly before the advent of Swift, it was much easier to have QA engineers who are used to writing automation scripts in JavaScript be able to just continue to write them in JavaScript rather than teaching them how to write those scripts in Objective-C. And, you know, allowing that to go to developers was maybe not the best idea, because, you know, you would write your UI tests in JavaScript and you would just really scream. And, you know, more accurately, iOS and OS X developers really didn't write any UI tests at all. So somebody said, okay, there's got to be a better way than this. And that somebody was Square, and they invented this lovely thing called KIF, which is Keep It Functional. And it was first introduced to facilitate what they call functional testing. Most of us call it UI testing. And Square engineers also hated JavaScript, and they thought that it was really silly that UI tests couldn't be written in the same language as their code. So they did a whole bunch of hacking and came up with KIFs. So it runs in the same process of the main application, since it uses a ton of private APIs. You know, you have to be really, really careful when you're setting it up to make sure that it wasn't included in your main application target, or you would be immediately rejected from the App Store. It was a giant pain in the butt to install before CocoaPods. It also adds a really, really huge third-party dependency to your application. I will note it's a lot easier to install with CocoaPods. And now there's this brand new way that Apple has introduced. So there's XCUI. So it's available for Xcode 7 in iOS 9 and OS 10, 11, and higher. It's available in Objective-C or Swift, and you can use it to record interactions to generate test code automatically, which is pretty awesome. Your tests run in a separate process, and I'll get to sort of the pluses and minuses of that in a little bit. And it's basically a much, much better way to interact with the UI automation APIs. And when it was first introduced, there were a lot of bugs. My favorite was that you couldn't really scroll a table view with it. And if you actually watch the demo from WWDC, you will notice that they very carefully avoid doing anything to demo these UI tests that require scrolling a table view. And luckily, that's been fixed. And there have been a fair number of radars over the last few months, and they've really gotten it working quite a bit better now. So how do these tests work? So, it uses this proxy object called XCUI application to access the app. Because your tests are running in a separate process, you need something which can reach across those processes and tap things, and that's what the application proxy is, which has access to all the accessibility elements. It queries all of the UI elements on the screen by type, and then you can look at your tables, sliders, segmented controls, steppers, and navigation bars, and toolbars, and static texts, and text fields, and buttons, and also images. You can go ahead and you can find out what things are on the screen, and then take action against them. And so the code winds up looking something like this. XCUI application.buttons tap me.tap. And what this command is essentially saying is use the application proxy to find all of the buttons on the screen, then take the one from that list with the title or accessibility identifier tap me and tap it. And this really is the simplest way to interact with your application, and it's really a lot easier than trying to figure out how to make TIFF work. James Dempsey has taught me how to enjoy a really good gratuitous transition. So now it's time to get ready for demo number 1, adding and recording XCUI tests. All right, so I live in Chicago, Illinois, and I'm a big baseball fan, and I am what's called a shameless bandwagon jumper. So for those of you who aren't familiar with this term, it means that I like to root for teams that are winning. And when the Cubs started winning a lot of baseball games in the fall of 2015, I started following them a lot more closely, and I wanted to keep track of how they were doing. Now, I also used to live about a mile from the stadium where the Chicago Cubs play their home games, which is called Wrigley Field. Now, when the Cubs had a home game, the parking in my neighborhood turned into a complete nightmare because of the crowds. So I made this little app that had 2 basic functions, and so it would show me how the Cubs had done during the regular season and the postseason for individual games, and then it would tell me if there was a Cubs home game today, so I'd know whether or not parking in my old neighborhood was going to be okay or horrible. So in order to take a look at the application, you can start by going to your RWDevCon code and selecting session 207, selecting demo 1 and starter, and then opening up gocubs.xcodeproj. And I already have it running as a shortcut. So build and run the application. So you'll see that there are 3 basic screens in this application. You'll see that the first one is just a table view of all the games that the Cubs played with the dates and their opponents and some colors on that. If you select a row in the table view, you'll see that there's some information about the results of the game. So you'll have the winner of the game and the loser of the game. Sadly, in this case, it was the Cubs. And then a little simulated flag, like one that flies over Wrigley Field when they win or they lose. So let's pick one. I think I know the Cubs won, and hooray, yay! So we get a nice little W flag. And you see the Cubs won and the Cardinals lost, and other information like that. So finally, if you go back to the main table view and then you click this little calendar icon up in the upper right-hand corner, there's a screen to check whether there's a Cubs game at Wrigley Field today or not. So now, let's go back to Xcode. And you'll see that there is already one set of tests that's set up. And you can see that they're already there to test some logic. So you've got some game checker tests and some CSV parsing tests and some calendar parsing tests. So in order to build and run those tests, grab that play button, go ahead and hit test. And we'll build the tests, think about running them, consider running them, compile some asset catalogs, file some Swift source files. Then we'll actually run some tests. And, you'll notice that since there's no UI involved, those tests run real quickly. One of the things that you can see here is that here we've got executed 9 tests with 0 failures in 0.620 seconds. So that's less than a second to run 10 tests. And that's pretty great. And that's actually fairly slow. I've often seen these be less than a second to run 40 or 50 tests. Now, when the tests are finished running, if you go to the report navigator, which is up here in the little speech bubble, and then you select the most recent set of tests which ran, you can actually see information when you click on this coverage thing, and you can see, okay, so here's how much of each file is being covered by tests. So you can see that, the Cubs record and the calendar parser are all doing pretty well. Then as you start to get down, anything with the word view controller in it is down here towards the bottom with nothing. No test coverage whatsoever. And so your goal today is to improve these numbers by testing not just the underlying logic of this application, but that everything is displaying properly to the user by using XCUI tests. So in order to do that, you've already got your Go Cubs tests non-UI test suite, and then you're going to add a UI test suite. So if you go to File, New, Target, and then you select in the sidebar, you've got your test, and then UI testing bundle, hit Next, and then your product should automatically be named Go Cubs UI tests. Make sure that the language is set to Swift, the project is set to the Go Cubs Xcode proj, and then that the target to be tested is Go Cubs application. Hit Finish, and you will see that you now have your test target added to your list of targets as Go Cubs UI tests, and then there's now a folder down here with Go Cubs UI tests as the name. If you open up that folder and then you select the Go Cubs UI test file, you'll be able to see what Apple gives you automatically. If you click this little diamond in the gutter here next to all of the line numbers, what that does is it will go ahead and start up a set of UI tests for you. So if you bring this up, one of the things that you'll see is it launches the application, and then it really doesn't do a whole lot else. So now it's time to take advantage of the best feature of XCUI testing, which is the ability to record yourself clicking around your application in order to generate some code. So in order to do this, let's go back to Xcode and then put a breakpoint at line 33 of test example, and then click this little diamond in the test gutter to build and run your tests one more time. And you'll notice that it will go and it will start getting the test up and running, and then all of a sudden it will hit that breakpoint. In theory. Come on. There it goes. And when it hits that breakpoint, you want to make sure that you put your cursor at the end of line 33 to make sure that as you're recording the test, that things are being recorded in the correct place. Now to actually start recording, you can use this lovely little red button that says Record UI Test, so hit that red button, and it will start recording your UI test. Now, one of the things you'll notice if you go back to Xcode is that you have this lovely little gray bar here that will indicate where your UI tests are actually getting recorded. So now, if you go and let's go ahead and select the game on October 10th. So if you click right on that Cubs versus Cardinals there, and then it does that. And then if you click on where it says Cubs, and where it says 6, and where it says Cardinals, and where it says 3, all of these will sort of say, oh, okay, we're going to be tapping on stuff. And now, if you actually go back and look at your stuff, you're able to see that your application is going to be looking through your tables and your cells containing types, and then it's going to look for Cubs, Cardinals, 6, and 3. So in order to stop recording your UI tests, you go ahead and hit the same button that you hit to start them, which now says Stop Recording UI Test. And now, you can actually take out that breakpoint and then build and run the test, and let's see what happens here. So one of the things that you'll see is that when it launches, the UI tests will actually go ahead and tap where you tapped, and then it actually takes a moment to go through and see what's going on. If you actually watch when we do this, the information coming through on the logs, you're able to see that after everything launches, it sort of waits and it goes through and it actually makes sure that everything is where it needs to be. And then it actually goes through and taps every single thing that's in the application. And that's not really terribly a fast way to do this. So let's take some time to add actual tests to the application. So in order to do that, one of the things that you're going to want to do is take advantage of some features in XCTest, where you're able to say, okay, I want to make sure that each of these things actually happens. So each of these various static texts has this Boolean computed variable called exists. And what you'll do is you'll change this tap to dot exists. And you can do that, and you can just sort of copy paste that to each of those taps. And then, okay, let's run your tests one more time. And then, let's go. All right, let's see how it goes. So it launches the test application, and then that in turn launches the actual application. It taps, and hey, that was a lot faster. Okay, sweet. So let's go back over here, and let's make sure that this actually fails when we expect it to. So at the end of the test example, what you want to do is you want to say, okay, let's check that something that definitely is not there is not there. So or is not there. So like now, okay, let's see app. Static texts, and then you can give it the name nope exists. Okay, so theoretically this should fail, right? So let's build it and run it, and then it'll go. Let's go back over to the simulator. So the test process launched, and then that in turn launches the actual application, and it goes through everything, and hey, wait a minute, that still passed. And what it turns out you need to do to take advantage of this Boolean value is to actually use XCTest information in order to make sure that it's working. So in order to do that, there's a really simple XCT assert true, and what that does is it says, okay, I am expecting this Boolean to be true. And so you can add that to each of your various items, and then just add some closing parens here. And then you build and run your test one more time, that test example. Your build should succeed. It'll go, and then the app itself will launch, and it'll poke the thing, and it'll look at everything again. But this time, XCT assert true failed. And so now we know that it's actually going through and looking for stuff. So now you can delete this line, and you run it one more time. Run that test example, build it. Again, we'll sort of launch that test process, then it will launch the application itself. And it'll tap on the thing, and it'll check. And hooray! Our little green checkmark friend is back. Huzzah! So the good news is that you've been able to check for the presence of the few items, but the bad news is that this test so far doesn't actually tell you if the items are showing up in the correct place. So the app is set up so that the winning team's information should be on the left, and then the losing team's information should be on the right. So we'll take a look at this here. So we've got the Cubs on the left and the Cardinals on the right here because the Cubs won this game. And we've got the, let's see, I think the Cubs lost this game, so the Cardinals are on the left, and then the Cubs are on the right. Now, in order to verify that things don't just exist, but they're in the correct place, you want to take advantage of the accessibility APIs. But before you get started, there's a couple of things to understand about how accessibility and UI automation work that you need to make sure you understand before continuing. So the biggest one is the difference between accessibility labels and accessibility identifiers. Accessibility labels are pretty straightforward. They're text which is associated with a UI element which is read out loud to a visually impaired user. But what if there's something that UI automation might need to know in order to verify things are appearing in the correct place, but it's not necessarily a piece of information that you'd want read out loud to blind users? So Apple added this accessibility identifier property to allow you to do just that. Now that you've seen the difference between accessibility labels and accessibility identifiers, now you can actually go into the file navigator, and you'll notice this folder called dstringers. And you'll notice that there are several different things. We've got some helpful localized strings. You've also got a set of accessibility identifiers, which are all regular strings, and then you've also got some accessibility labels, which we'll get to in a little bit. So the accessibility labels are gonna help you with one of the most frustrating parts of UI testing, which is making sure that you're using the same spelling, capitalization, or language information between your tests and your application. So when you're using hard-coded strings like this, like winning team score, rather than something that actually helps centralize all this, it's a lot easier to spell or capitalize things inconsistently, and this causes tests to fail because they're looking for the wrong spelling or capitalization. You'd also need to keep an eye out for any changes to the text within the application and make the matching updates to your UI tests. So centralizing these references in these files prevents both of these problems. Breaking things into these specific files for each type of string really helps you keep an eye on which type of string you're working with straight. And, setting these things up is a little bit more time consuming up front, but it saves you a lot more time down the road when your application changes. So for this demo, you can open up accessibility identifier.swift, and then you can see that all of these values are set up directly as string enum values. And why is that? Because accessibility identifiers are never going to be read out loud to visually impaired users, so they can just be raw string values. So there's one little complication with this string centralization technique and XCUI testing, and that's because the UI tests run in a completely separate process than the application, so you can't even do an @testable import of that main application. So you actually need to select all three files in this folder, and then you need to check the Go Cubs UI tests target membership so that they can actually be seen by the UI tests. So now that both the app and the tests can see the same app information, it's time to add the accessibility information to the app. So all the view controllers in this application, which you can find in this lovely view controllers folder, they all have these methods called setup, accessibility, and localization. And you'll notice that sort of when you look in each of the view controllers, the localized strings are already set up. But if you go to game detail view controller.swift, and then you select setup, accessibility, and localization, you'll be able to start adding in the information that you need to. You want to make sure that you're not messing up what gets read out loud to those visually impaired users, which in this case would be the team name and the score for each of the teams, but you also need to add accessibility identifiers so that your tests can actually see what you're trying to do. So in setup, accessibility, and location, where there's this lovely to-do, you can go ahead and delete that. And then you can add the lines which associate the winning and losing team name labels and score labels with the proper accessibility identifiers. So start with losing team name label, dot accessibility, identifier equals accessibility identifier dot losing team name. And then go ahead and say losing team score label dot accessibility identifier equals accessibility identifier dot losing team score dot raw value. And I forgot to add dot raw value on that one. And then winning team name label dot accessibility identifier equals accessibility identifier dot winning team name dot raw value. Winning team name label dot I already named the label score label dot accessibility identifier equals accessibility identifier dot winning team score dot raw value. So now that each of these accessibility elements has been assigned an identifier, you can actually use that identifier to grab information about the contents of the accessibility element it references in the test. So now you're ready to re-record those tests with the proper accessibility support. So if you go back to your Go Cubs UI test, and you go back to gocubsuitest.swift, and go ahead and just delete this entire test example method. Yay! And then you're going to add a new function called testKnownWhen to help you remember what your test is actually testing. So you say func testKnownWhen, and then you can say this is October 10th. Cubs beat the Cardinals 6-3. And so again, make sure that that cursor is right by that comment, and go ahead and hit the record button. The app will launch, and then you can go ahead and start recording your UI tests. So again, go ahead and go to the October 10th Cubs versus Cardinals game. Click on Cubs versus Cardinals, and then you click Cubs 6, Cardinals 3. And then you go back and go ahead and stop recording. And you'll see that there's these new little blue highlights these are indicating that there are multiple possible values that could represent a given element. If you click on them, you can see that you have both the winning team's name and you'll also have Cubs, which is the actual literal string that's on there. Now, since the winning team's name could change, you want to use that winning team's name there, and when you select that and hit return, that takes away the option. And you can do that over and over and over again. Whoop. And you've now got everything. So now you can also easily, because you know that you've just set up all these accessibility identifiers, you can actually now easily replace these hard-coded strings. So you can say accessibility identifier dot winning team name dot raw value, and you can get rid of that. And you can do the same thing with these other ones. Accessibility identifier dot winning team score dot raw value, and get rid of that. And then you've got accessibility identifier dot losing team name raw value, and accessibility identifier dot losing team score dot raw value. All right. So you'll remember from the first go around that you can't simply ask the UI automation tool to tap on everything expecting to catch mistakes. So you actually need to test that the values are what you expect them to be. So since you're using the accessibility identifier to access a particular accessibility element, how do you tell what's actually on it once you've got it? So in this case, you're actually able to grab the information using the accessibility labels. So the good news with UI labels is that the accessibility labels that are read out loud to users who are visually impaired are populated dynamically when each UI label's text property is set. You don't actually need to do anything you weren't already doing to set the accessibility label. So on the accessibility element, this property is simply called label. So you can take that value and compare it to what you expect it to be by using xct_assert_equal. So in this example, the Cubs won and the Cardinals lost this game, and in this view, the names of all teams are capitalized. So for the winning team, you want to change that to label, and then you want to use xct_assert_equal, and then you can say, okay, I want to say that the winning team name should be the Cubs, the Shouty Cubs, and then you can say, let's check the name of the losing team. So we've got xct_assert_equal. Let's grab that here because I'm a terrible typist. And then say instead of tap, that should be the label. And then this should be the Cardinals. And put that in there. Let's take a look and see what we've got here. So we'll run it, build it and run it. We'll think about running, consider it. Launches. It goes and it says, okay, I'm going to look and I'm going to make sure everything's in the right place. And something did not happen there. Or it just took a while to finish. Okay, sure. Thanks, Xcode. And then again, you want to make sure that okay, is it looking in the right place? Are things correct? So one of the things you want to do is sort of say, okay, if I make something really obviously wrong, like calling the Cubs the Cubes, let's see if that actually fails. So let's change that name and tell it to look for that again. So it launches the test process, which then in turn launches the application. And the app launches, it taps, goes, and ta-da! The cubs is not indeed equal to the cubes. So go ahead and delete that E just so the next things don't fail. And then let's go ahead and check that the correct information is getting put in for the scores. So again, you're going to access the label of the static text. And even though this is a number that's on it, it's a string that's surrounded that is being grabbed off of label. So you need to actually say that the score is a string of 6, and then label, and then this is going to be 3. And we're going to say XCT assert equal. And now you can go ahead and say, oh, okay. Let's go ahead and take a look at this and make sure that this is now passing. So it'll go. It'll think about launching. It'll consider it. It launches. It goes. It taps on a thing. It looks at everything. Hooray! It passed. So that's sort of the way to set everything up in a way where you can check that everything is correct and make sure that everything is doing what you want to do. Now, here's where the real value comes in, which is trying to redo stuff. So let's test a game that we know that the Cubs lost. So not October 10th. Let's say August 29th. So this is going to be, instead of test known win, because it's going to complain about this, test known loss. And so on August 29th, and then Dodgers beat the Cubs 5-2. And so you can change this to Aug 29, and then Cubs versus Dodgers. And then you can say, okay, so you can say this is now 5 and this is now 2. And Cubs are now the losing team, and the winning team is now the Dodgers. And now you've actually gone ahead and created this entire new test method that will go, and when you build it and you run it, it launches the test process, and then it will actually use the application and the information that you've already set up to go ahead and scroll down to August 29th, and then check that the Dodgers did, in fact, beat the Cubs 5-2. And you can now see that that passed. Hooray! So you've now learned how to add XCUI tests to your application, and how to record basic UI tests, and then how to use accessibility identifiers so that your UI tests can access specific elements and verify that their contents are correct. So take a little break, and then it's time to move on to using accessibility labels to help both your UI tests and your visually impaired users across all parts of your application. All right, so welcome back for part 2, testing and accessibility. So in that first demo, you learned how to use accessibility identifiers to help your test pick out which accessibility element was which, so that you could make sure that the correct information was displaying in the correct place. Now in this demo, you're going to go one step further and add information that both your tests and your visually impaired users can use to navigate your app in a way that makes sense. So to start off with, let's try to understand what the difference between an accessibility identifier and accessibility label are. Identifiers are for testing only, whereas labels are for both testing and visually impaired users. So identifiers only show up in a way that testing can be used, and then the labels will show up for visually impaired users as well. Identifiers are really useful for helping distinguish very similar views, like the ones that you were just trying to distinguish between the two score views. And then the labels help you find specific singular views, so something that's really only going to show up once, but also that potentially could be something that a blind user or a visually impaired user would have difficulty seeing and would really need described to them. So one thing I want to note before I go on, testing makes accessibility an easier sell to business people. This is something that I've really found a lot. And I've also seen the opposite, where accessibility actually makes testing an easier sell to business people. In my experience, business people are a lot more willing to see testing as a good investment than accessibility, because they sort of see the idea that, oh, our app is tested. There are ways that we can understand whether it's going to fail for our users as a good thing, because they don't want the app crashing for people. Whereas they don't necessarily see from a monetary standpoint what the benefit of accessibility is. So, in reality, what you're doing is you're making your app more usable to a much, much wider array of users, and that is always a good thing. Now, making accessibility labels useful is sometimes a little bit weird for those of us who are sighted. They should be really short. When they're read out loud, they should tell the user what will happen if that element is selected without taking too long. And these elements should also be localized. It would be really weird if you had your whole app translated into Spanish, and then suddenly you hit a button and it said calendar, or in English or something like that. Remember that these are user-facing strings, so therefore they need to be localized. Another tip from Apple is to not include the name of the control. So Apple gives the example of a button in a music app that has the accessibility label play versus the accessibility label play button. So VoiceOver, the thing that actually goes through and reads accessibility labels out loud to visually impaired users, it will already be telling the user that this item is a button. So adding that information to the accessibility label itself is redundant. It would come out as play button, button. And that just sounds silly. My strong recommendation is to create something which centralizes your accessibility strings so that you can ensure that they're the same across targets. This is not necessarily a thing that Apple necessarily recommends, but it's something that I have found in practice saves you a lot of heartache in terms of retyping everything, in terms of errors when you've misspelled stuff. It just makes your life a lot easier. And you're going to see an example of that in the demo app. And speaking of which, it is time for the second demo. Woo! So you want to close out the Xcode project you were working on from demo 1. You can't use it for demo 2. So to get started for this demo, you can go back to 207 and then select demo 2 and select the starter project and then open up gocubs.xcodeproj. And then we're going to put that back into full screen mode. And to make things a little bit easier to follow, there's been a little bit of refactoring done. So if you go to gocubs UI test and open up gocubs UI test.swift, you're going to be able to see that we've gotten rid of some of the copy-pasted code and we've gotten rid of some of the extraneous comments. So there's now 2 helper functions. You've got your test known win and your test known loss, and there's also been a test known postponement that's been added. And so you've got these 2 helper functions. You've got select game with date string and the versus string, and then check result of game with the expected winning team, losing team, and the scores for each of them. So if you scroll to the top of the application, or to the top of the file, and you build and run the tests, and this will run all 3 tests in the gocubs UI test.swift file. Go back over to the simulators, take a look at what we've got here. So the first test will run, and it'll check to make sure that the Dodgers did in fact beat the Cubs, and then the application will close out. It'll get launched one more time, and then it will check, I believe this will check the Phillies game. Yeah, so this will check that the Cubs and the Phillies got rained out, and then finally it will launch the app one more time, and it will say, okay, let's check that Cubs-Cardinals game. Hey, the Cubs did indeed win. You go back, hooray, everything passed. So now that you've sort of had that chance to take a look at what everything is doing with centralized code, we want to take a look at what accessibility labels are and how to use them in both your tests and how to help visually impaired users. So, like I said, it's often really helpful to think of the computer running your UI test as a blind user. Since it doesn't have eyes to look at the screen, it can't access anything in your app without using the UI accessibility elements, which a visually impaired or blind user would be using to access your app via VoiceOver. So you need to make sure that the computer has enough information to figure out where to click and tap in order to perform your tests. When you give your computer this information, you can also choose to give this information to your visually impaired users at the time whenever it's appropriate. So while the accessibility identifiers you added in the previous demo are only visible to UI automation testing, accessibility labels are visible to those same tests and also read out loud to a visually impaired user by VoiceOver. So now you can reopen this dstringers thing here, and you can go to accessibility label. Now here you'll see that there's still an enum, but there's actually a bunch of static let constants on that enum which have NS localized strings. Now, because these are localized, and remember this is localized so that everything being read out loud in one language doesn't suddenly get read out loud in another language when accessibility kicks in. When you're working with enums, you can't actually have an enum value that's a string be a dynamic call, which NS localized string is. So you have to use static let to set up those constants in advance. So sometimes the text on a UI label or a UI button isn't really sufficient to explain to a visually impaired user what it represents. So it has to be reset after the sighted user-facing text is set. So you're going to learn how to reset the accessibility label, then test that the correct value is displayed in the correct scenario. So in each of the three scenarios, win, loss, and postponement, a flag is shown, which makes it easier for sighted users to tell the result for the Cubs at a glance and to mimic the actual flags that fly over Wrigley Field after games. However, for visually impaired users, simply having VoiceOver read out W or L might not be enough context. So an accessibility label will give visually impaired users a bit more context. So if you go open up the view controllers and select again the game detail view controller, and then you can go down to, there is a configure flag for ResultType function at the bottom. Now, that function takes a ResultType enum, which has information about whether the Cubs won or lost the game or whether it was postponed, and then it uses it to configure that flag. So fortunately for you, the ResultType already has an accessibility label computed variable. If you actually click through to ResultType, you can see that you've got the accessibility label, and it actually gives you back the proper accessibility label item there. Go back. So all you have to do is you can say result label dot accessibility label equals result type dot accessibility label. And the next thing that you want to do, now that you've said, okay, here's the accessibility label, is you want to make sure that the correct flag is showing. And unlike with the team names and scores, since there's only ever one flag displaying at a time, you don't actually need to grab the element before checking its label. You only need to check that the expected flag exists, since if the expected label isn't displaying, it won't actually exist anywhere else on the screen. So if you want to continue to take advantage of the centralization, go back into Go Cubs UI tests, and then check result of game with expected winning team, expected losing team, and then you're going to add a new call where it's going to say expected flag, and that's going to be a string. And then you can say, okay, xct assert true, and then you say app static texts flag expected flag exists. So you're only checking for the existence here. Now, this will sort of break a couple of things here because these were already calling it, but it's really easy to fix it. So you add the expected flag, since this is a known win. You can say accessibility label dot Cubs win. And then in this one, change that up to say expected flag, accessibility label dot Cubs lose. And then finally, this last one, expected flag, accessibility label dot postponed. And so now you can go ahead and go back up to the top and run these tests. And now they're going to run on the simulator. And hooray! Now it's actually going to go through and run all three tests again, and it'll actually be checking every single time whether this expected flag that you're passing in exists. So obviously this first one passed, now the second one is passed, the third one's running. It's going to go launch the Go Cubs application, and then it's going to select Cubs versus Cardinals, and hooray! Okay, and that one worked too. So you always want to double check that things fail when you give them bad data. So here in the known win, We know that it passes with the Cubs win. Let's see that it fails with postponed. So just run that one more time. And then it will launch the test application there. And then it will launch the actual app. It'll select that win. It'll show that thing. And ta-da! ExpectedFlag exists is false. So then you can make sure that that actually goes back to where it needs to be by changing it back to Cubs win, and then making sure that that passes one more time, just to make sure that you don't accidentally get failures in the next section while you're working. So in this case, it looks like that'll take a moment to go. So the next thing that you want to do is make sure that now that you're going to and from the game detail view controller and verifying its contents, that you can actually get in and out of the game today view controller. So conceptually, since this is actually fairly different from the game today view controller, or excuse me, the game detail view controller, you're going to want to add a new test file for this. So make sure that you've selected the Go to Cubs UI test folder so that your file goes in the correct place. And then go to File, New, File, and then select a UI test case class, hit Next. Make sure that it's in Swift and that it's a subclass of XC test case, and then call it Game Today UI Tests. Hit Next. Make sure it's going into the Go Cubs UI test folder and into the Go Cubs UI test target, and then hit Create. Now, in order to start using this for tests, you'll need to add some accessibility labels to your existing view controllers in order to make sure that your tests can see what buttons they need to click. So go into the Cubs 2015 table view controller. That's the table view controller that provides the main table view that you see when you launch the application. And in Setup Accessibility and Localization, add a new line and say Game Today button dot accessibility label equals game accessibility label Game Today button. And that's going to give an accessibility label to the little calendar button up in the top right corner of the view controller. And then in the actual Game Today view controller, now you want to be able to close the thing out again. So you can say close button dot accessibility label equals accessibility label dot close button. And again, that gives the accessibility label to the little X button that is available to you in that view controller. So now, go back to Game Today UI test.swift, and you can clear out the test example here, and add a new test called func test navigating to and from Game Today. All right. And then make sure that you put your cursor sort of right there. And then you're going to go ahead and take advantage of recording to record the new accessibility labels that you've added. So hit that record button. It's going to go at some point, potentially. All right. And it's launching the application. And now click on this button here, the Game Today button. And then now you can also click on the close button. If you go back to the test, you can go ahead and stop recording. And now you can see that you've got all sorts of fun stuff with what you're looking for in here that you've already recorded. So since there's actually localized strings for this navigation bar, you could actually say that this is localized string dot list title, and replace that hard-coded string. And then since you just added these two accessibility label, you can say accessibility label Game Today button, and then accessibility label close button. And now you're able to see that all of those are actually in there. So now what you want to do is build and run, and you can see that the test will come up, and then when it actually launches the application, come on, There it goes. It will tap, and then it will tap again. Hey, that's really great. And it actually does everything that you need it to. So, the logs indicate, if you actually sort of look at the logs that come in when you are watching everything, you'll see that everything goes through a process of like waiting for accessibility to load, waiting for the app to idle, and it goes through and then it finds things. And when it waits for the app to idle, and then it synthesizes an event, it actually doesn't necessarily wait for the app to idle completely, and you don't necessarily know that something that's supposed to be gone is gone. So how do you check that? So one of the things that you sort of want to be able to do is say, okay, if we accidentally don't close out so if we don't close out the Game Today view controller, so like let's say we go into Game Today view controller, and in the close function, just comment out dismiss view controller. So if you were to run the Game Today UI tests as they are right now, that's test navigating to and from Game Today, it'll go, it'll build, it'll run, and it'll go at some point, and I'll hit that, and I'll hit the close button, and it'll still think everything's okay because, hey, it hit the close button. So how do you check that? How do you verify that that's actually what you want? So the best thing to do is to say, okay, we know that the close button is actually a button that we can get, so you pull it out into a variable. So let close button equal, and then sort of say all of that stuff, and then you can say close button dot tap, and then after that tap has taken place, you can say xct assert false close button dot exists, and what that'll do is it'll say, okay, after I tap on the close button and the screen settles down, I want to make sure that that close button is actually gone. So now, if you build it and run it, we'll go. And now, oops, it failed. Hooray! Now here's where you can actually check out a really neat feature of XCUI test, which is automatic snapshots of tests failing. So if you go over to the report navigator and then you select the set of tests that you just ran, so it's just the test navigating to and from Game Today, you open up that flippy triangle, and if you sort of open all of the flippy triangles, you can start to see that various ones have these little eye icons next to them. And you'll see that when you tap on one of the eye icons, it shows you a screenshot of what was happening. And so one of the things that you can do by doing that is you can actually go through and you can say, okay, what is the last screenshot that happened before my assertion failure happens? So if I go and I sort of open all the flippy triangles and I look and I say, aha, wait for app to idle. And I hit that and I see, oh, I've tapped the close button, yet it is still there. Oh, that makes it a lot clearer for me that this is not actually doing what it needs to. And you're able to quickly narrow down what the problem is when your tests fail. So for this tutorial, you've added accessibility labels to your application to help both your tests and your visually impaired users, and you've seen how to grab a screenshot of your test at the time of failure to help you figure out what went wrong. So now you're ready to move on to the hard part, which is covered in the lab, which is passing data to the application process from the test process. All right, and it is now time for the dramatic conclusion. All right, so what did we learn today? So you took, in the first demo, you were able to add and record UI tests for an existing application. And in the second UI test, you were able to take advantage of those UI tests and accessibility labels. And in the lab, you were able to let the app know it was being tested and pass in information as you were going. Now, where do you want to go from here? There are a bunch of resources that I would recommend to start with. The first one is WWDC 2015 session 406, UI testing in Xcode. That's where all of this stuff was introduced. Kate Houston has a really great blog and book called iOS Unit Testing Beyond the Model. Joe Mazzolotti has a bunch of really good blog posts, including one called the UI Testing Cheat Sheet and Examples. And then Greg Hio's got a really great testing video tutorial series here on raywenderlich.com. There's him waving right there. And then you can also come annoy me on Twitter. I am at Designated Nerd. I talk about testing all the time. Also, I talk about everything else in the universe all the time. So, yeah, sorry if I clog your timeline. Thank you guys again for everything, and have a good afternoon.